This video covers setting the workpiece origins for the Heliner 4-axis rotary CNC router and is part of the larger rotary machining series. In our program, we have set the workpiece origin to the center of the stock, which is good practice as this position remains consistent regardless of how the part rotates. The workpiece origin in the machine must now also be set to the physical center of the stock that is currently fixtured in our chuck. There are several ways to do this. Here we'll outline a basic method that involves touching off the spindle on all four sides of the stock and then calculating the center. Start by setting the x-axis origin. Bring the tool into contact with one side of the stock. And then zero the relative x-coordinate at this position. Now, touch the tool on the other side of the stock. Observe the relative x-coordinate. The stock width can now be calculated as this coordinate minus tool diameter. Now, set the x-axis workpiece origin to this position. Observe the machine's x-coordinates. To set the workpiece origin to the center, we need to use the following formula. The x workpiece origin is equal to the current x machine coordinates minus the stock width divided by 2 to bring the origin to the center, minus the tool diameter over 2 to account for the fact that we touched using the edge of the tool rather than the center. Manually enter this calculated value into the G54 x coordinate. The workpiece origin in the y-axis can be done roughly as we have a lot of material to play with. Simply move it to the desired location and roughly check the machining boundaries using a vernier or other measuring device. The head we are machining is approximately 75 millimeters and will be machined within these boundaries. Set the y-axis workpiece origin to the current location. The procedure for setting the z-axis is essentially the same as the x-axis. Move the z up to a safety height. Rotate the rotary axis 180 degrees. Touch the tooltip to the top of the material. Then set the relative coordinates to 0. Press tooltip measure, then Z delta set to automatically set the Z height after the tool has been measured. The calculations for the stock width and Z workpiece origin coordinate are the same as the calculations we did for the X, except we no longer need to worry about the tool diameter. Once again, manually enter the calculated value. Everything is now set up and machining can begin. However, first it is always good practice to manually check the full limits of the program to ensure there will not be a clash with the rotary axis. Observe the absolute coordinates on the positioning screen. The tooltip is at the workpiece origin when these coordinates are 0. To verify the setup, move the tool sequentially to the X, Y, and Z origins. Since we know the exact dimensions of the part to be machined, we can manually drive the tool to the part's outer extents. This allows us to confirm that the tool path is clear and no collisions will occur during machining. If you'd like to learn more, head over to our website or give us a call. Thanks for watching.